Hey there, Seahawks. It's Miss Adams, and in this video, we're going to talk about estimating a population proportion. All right, so checking conditions. Bryce wants to estimate the proportion of the juniors at his high school who like to wakeboard. He interviews a simple random sample of 60 of the 150 juniors on campus. He finds that 19 like to wakeboard. Is the random, independent, and normal conditions for finding confidence intervals met? So these are the three conditions that we would need to meet in order to do a confidence interval. So random was a random sample taken? Well, yeah, it was stated that they took a simple random sample. The independence condition is also known as the 10% condition, is where our population has to be greater than 10 times our sample size. All right, so this is a little bit tricky because there's three numbers in here. There's 60, 150, and 19. Well, 60, he took a sample of 60. So 60 was the sample size. There are a total of 150 juniors at this school. And then he finds 19 of them like to wakeboard. So 60 was the sample size. So 150 is, we're checking is 150, which is the population, greater than 60 times 10, which it is not. 150 is not greater than 600. So that condition is actually not met. A lot of times with this condition, you'll be assuming that it's met. You'll assume there's more than 600 juniors at the school in order to meet that condition so that you can proceed. But I wanted to show you what it looks like when they are not. So no, the independence condition is not met. And then the normal condition, it can either be stated that it's normal, or you can check that there's at least 10 successes and at least 10 failures. So n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. So first I have to figure out what is p. All right, so p hat, which is our sample proportion, would be 19 out of 60. We took a sample size of 60, 19 of them said they like to wakeboard, which works out to be 0.3167. So that's what I'm using for p. N is the sample size, so n would be 60. So I'm going to do 60 times 0.3167, which gives me 19, which is greater than 10. And then 60 times 1 minus 0.3167, which gives me 41, which is also greater than 10. So the normal condition is met. All right, interpreting a confidence level. In a recent school newspaper survey, 4,000 randomly selected teenagers were asked to cite their primary transportation method to school. 18 of 25 teenagers said they used their own car to get to school. A 90% confidence interval to estimate the true proportion of teenagers who drive their own car to school is found to be 0.5826 to 0.9173. Which of the following is a correct interpretation of the confidence level? So interpreting the confidence level is a little bit different than interpreting the confidence interval. All right, so the confidence level is saying that if I did a confidence interval many, many times, 90%, because it was a 90% confidence interval, 90% of my intervals would capture the true proportion. So in my picture here, that green bar, that's the true proportion. Okay, and so then I did all of these different intervals, and my intervals are all going to be the same size, but every time I do them, I'm getting them from samples. So every sample is going to give me slightly different values, and so their intervals are going to be slightly different. And 90% of the intervals will capture the true proportion. So 90% of the intervals will capture the truth. Not every single interval includes the truth, but if I did it many, many, many times, 90% of them would. All right, so 90% of the time, the procedure used to generate this interval will capture the true proportion of teenagers who use their own car to get to school as their primary transportation method. Okay, and you can see that those blue ones that I outlined, those are the ones that don't capture the truth. Every other one, the gray little lines, every other one of those intervals captures the true proportion. The true proportion would be that green bar. All right. Estimate a population proportion. Faculty members at Sunlight High School want to determine whether there are enough students to have a after COVID-19 prom. 129 of the 250 students surveyed said they would attend a prom. Construct and interpret a 95% confidence interval for P. All right, so 129 of the 250, and then it's 95%. So our confidence interval is equal to P hat plus or minus Z star times the square root of P times 1 minus P over N. All right, P hat would be 129 out of 500. That's our sample proportion, which works out to be 0.516. Z star for 95% is 1.96. So in our previous video, we said you might want to memorize some of those. The square root of our proportion, 0.516, times 1 minus 0.516 give me 0.484 over N, which is our sample size of 250. All right, and so now I would do 0.516 times 0.484, divide that by 250, take the square root, times it by 1.96, and then add it to 0.516 and subtract it from 0.516, and I get 0.4541 to 0.5779. Now, of course, I am going to show you how you would do all of this, kind of skipping some of these steps using your calculator. All right, so I want to show you how you would do that in your calculator. So again, let's get rid of this. We would do stat, we would go over to tests, and then we are going down until we find option A, which is 1 proportion Z interval. 1 proportion Z interval. So X would be the 129, I think it was. Scooch this over. Yeah, 129, N would be 250. So 129, N is 250, and this was a 95% confidence level, so 0.95. Calculate, and we get our interval 0.45405 to 0.57795. Okay, sometimes when you do it by hand and when you do it in the calculator, you'll get slightly different values just because of rounding and things like that. All right, go Seahawks.